This is Test Review, Module 3, Video 2. We are on the second side of the first page. Question number 8. Dory claims that 3.52, or 3 5200ths, is not a rational number because it is not written as a ratio of integers. Is she correct? Explain why or why not. Well, the definition of a rational number is when you can write it as a fraction in the form of a over b. Could I write 3.52 as a fraction in the form of a over b? Could I do that? You can, and here's why. 3 5200ths could be written as 3 52 over 100. And 3 52 over 100 is not exactly in the form of a over b, but it's one step away. Because 3 wholes, if the denominator is 100, means 3 100ths. And then 52 on top of that would be 352 total out of 100. 352 100ths is written in the form of a over b, which is a rational number. So Dory is incorrect. Comma, it is a rational number. Okay, question number 9. The title of question number 9 states, times in 100-meter dash. If you examine the table, you notice 4 runners, and they each have a time, and they're all somewhere in between 12 seconds and 13 seconds. And the directions say 4 runners ran the 100-meter dash. The times are shown in the table above. Which runner had the fastest time? Be careful on a problem like this. A lot of kids want to quickly go and find the biggest number, because in most events, the biggest number would be the winner. But in this case, we're actually looking for the lowest number. This is a 100-meter dash. It's a race. The winner is the person that ran it the fastest and got the least time. So right off the bat, we can actually eliminate one of the answers. They're all 12 seconds. You notice that. So now what we have to do is go to the 10th place. And if you look at the 10th place, I've got a 4, 5, 4, and 4. Well, 5 is the highest time. That person actually was the slowest. Corey is definitely not the winner. So now I've got 12.4 3 times. Now I just have to look for the hundredths place, and that will be the tiebreaker. Looking for the lowest, I've got 5 in the hundredths, 8 in the hundredths, and 4 in the hundredths. That means Shelley is the fastest time. We are going to stay on the top of the page and work on number 12 now. 12 reads, if x is a rational number and y is the opposite of x, why do x and y have the same absolute value? Well, a couple things we got to think about here is what a rational number is. We just reviewed what that is on number 8. A rational number is anything that can be written in the form as a over b. Believe it or not, that could actually be a whole number. It could be a negative number. Examples of rational numbers include something like 3 over 8 or 7 wholes, which is 7 over 1. They could even be negative. Regardless, it's a good idea to assign a value here. It says if x is a rational number. Let's just pick a rational number and make x be that number. Let's make x be 0.9. Now read carefully. It says, and y is the opposite of x. Well, if x is 0.9, what does y have to be? Well, opposite, by definition, is a number that's the same distance from 0 on a number line. Well, the only number that's the same distance from 0 as 0.9 is negative 0.9. In other words, it's all the same digits, but with the opposite sign. The question then says, why do x and y have the same absolute value? Well, the definition of absolute value is distance from 0. So I would say because they are the same distance from 0. Number 13, daily temperatures in Chicago. You'll see 4 days, Monday, Tuesday, Wednesday, Thursday, and you'll see their temperatures, and you'll notice them all being in the negatives. It is noteworthy that Tuesday is -2 and all the rest are -1 point something. Read the question. The table shows the daily temperatures for a 4-day period in Chicago. On which day or days was the temperature lower than -1.5? It's important to note a piece of directions here that you need to catch on to. It says in which day or days. Please understand that that could mean there's one answer. It could mean there's multiple answers. It's really important that you catch that. Now I'm going to move this up just a touch. And we should be able to see everything now. And what I'm going to do here to provide a visual is I'm going to turn this answer line into a number line. Because a number like this is awfully easy to, if you can't see it, a question like this, it's awfully easy to get this backwards. I'm going to put 0 over here on the right because I don't actually need that. I don't need any positive numbers. And I'm going to put -2 over here on the left. I'm put -1 in the middle. And I'm just going to place these numbers where I think they would go. -1.2 would be just a little bit past -1. -1.2, and I'm going to put a dot there. And then I'm going to put -2 over here. -2.0 is the same as -2 wholes. -1.8 is almost out to -1.2. And I've got -1.4. And I've got them on the number line, but I need to reread that last question. It says, on which day or days was the temperature lower than -1.5? So in a way, I kind of need to go plot -1.5. -1.5 is right in the middle of -1 and -2. I'm going to draw a line there at -1.5 because I notice I've got 2 answers on the right and 2 answers on the left. And I just need to think about what lower means. Lower is less, and less on a number line is to the left. So the 2 temperatures that are to the left of -1.5 are -1.8 and -2. So while I did kind of ruin my chance to write my answer on my answer line, the answer to the question is -2.0 degrees Celsius and 2 answers, -1.8 degrees Celsius.